Hello, I welcome you all in this presentation related with the subject fundamentals of the manufacturing process, and in this presentation we will be talking about some special casting processes, and these special casting processes are slightly different from the sand mold casting process. So, the special casting processes. There are three casting processes, special casting processes about which we will be talking about. One is like shell mold casting process, then investment casting process, and then permanent mold casting process. So, in this presentation basically I will be focusing in the shell mold casting process. So, in case of the shell mold casting process, as it appears from its name, the shell word, a shell is prepared using a mixture of basically sand plus resins and plus additives. A mixture of these three is used for preparing one shell, which is used as a mold cavity for pouring the molten metal, so that after the solidification desired casting can be achieved. Advantage of this process is that it helps to achieve very close dimensional control as well as the surface finish. So, the main part related to this casting process is preparation of the shell mold. So, what we use for preparing the shell mold, basically mixture of sand plus resins plus additives. This mixture is first prepared. So, this sand mixture, sand can be of the silica sand or zircon sand, and depending upon the metal to be processed by the casting process, either silica sand or zircon sand or mixture of the two can be used. And normally the grain fineness, very fine grains, the sand grains of the fineness number 80 to 150 grain fineness number sand grains are used for preparing the shell. And these sand grains, depending upon the size, you see the coarse sand is used for, you can say, where even rough surface of the casting is acceptable, but if high degree of the surface finish is needed, then fine sand grains are used for good finish. So, the finish which can be achieved in this process is range like say 3 to 5 micrometer, which can be achieved using the fine sand grains. And this then a mixture of the resins, basically thermosetting resins are used, thermosetting resins like phenol formaldehyde is used as a resin, plus additives are these resins act as a binding element or binding member in the mixture to hold the sand as well as the additives. Additives are used basically to achieve the good surface finish and to reduce the thermal shock due to the pouring of the molten metal, and for this purpose like coal, dust and the magnesium dioxide are used as additives. So, these will be helping to improve the surface finish as well as reducing the thermal shock, so that the cracking and fracture tendency of the shell can be reduced when the molten metal is poured. So, all this mixture basically is prepared. There is a particular process wherein like the sand, dry sand which is free from any clay is provided with the liquid resins, and it is thoroughly mixed with resins, and the additives are thoroughly mixed for the use. So, this mixture of the sand plus resins plus additives is prepared, and then it is used for preparing the shell. So, what we will be doing basically this mixture is placed over the, this mixture is used for preparing the mold. So, say this is the chamber where this mixture has been kept, and in this one the pattern of a particular shape whose shell is to be prepared, say this is the pattern, this is attached with this cover and which can be opened and closed. So, this is the pattern which will be used for preparing the shell. This is basically a metallic pattern, mostly the cast iron or grey cast iron is used for preparing the pattern, and this pattern is basically heated. It can be heated from 100 to 250 degree centigrade. So, this heated pattern is fitted in this box which is carrying this mixture of the sand, resins and additives. And then what we do, we try to rotate this box so that it is up and upside down. So, in this situation what will be happening, say our pattern, this will be the location of our pattern, and whole of the sand now will be falling over the hot pattern. So, the sand with mixture with the resins and additives will be coming in contact with the pattern. So, resins will fuse and they will get stick to the surface of the pattern. So, one shell is formed all around the pattern like this. So, depending upon the contact time and the temperature of the pattern, contact time of the sand mixture with the pattern and the temperature of the pattern, cell of particular thickness is formed. Normally it is desired that the 5 to 10 mm thickness of the cell is formed. So, this is the situation. So, once it gets a sufficient time, then it is again brought in the same position where the shell where the pattern will be the upside and the sand mixture will be in the bottom. So, whatever is unused sand mixture is there, that will be at the bottom, and whatever the portion will get stick to the pattern, that will be forming the shell. So, in that case, now this pattern is taken out. So, this pattern say here is of shape like this with the presence of the shell all around the pattern. Like this. So, this shell now we need to take care of. There are certain things now about which we have to talk, like what are the factors that will be affecting the thickness of shell or the thickness of the cell which is to be used. So, like say there are two factors. One is pouring temperature of the molten metal and the size of casting and the complexity of casting shape. These are the factors that will be governing the cell thickness which we need to use. This cell thickness, as I have mentioned, depends upon the contact time for which the sand mixture remains in contact with the hot pattern plate, hot pattern, and the temperature of the pattern. So, there is a proper relationship which has been studied, and wherein, like say, the temperature of the pattern varying from 150 to 250 degrees centigrade is the temperature of pattern in the x axis, and y axis is the shell wall thickness in mm. So, cell wall thickness say varying from 2 to 10 mm. So, when 2, 4, 6, 8 and 10 mm. So, so this is what we will see, that when the contact time is for 5 seconds, then the rate of increase in the shell thickness with the change of temperature, there is a one definite trend that increase in temperature of the pattern increases the shell wall thickness, and we will see that when the time is like this 20 second or time is like this 10 seconds. So, there is an increase in the shell thickness with the increase in the pattern temperature. So, with the increase in pattern temperature, more and more amount of the resin will be melting, and the sand mixture will be forming the cover around the pattern to increase the thickness of the cell. And similarly, when it gets longer time, then so increase in the cell thickness with the increase in the contact time is due to the increased availability of the time for which heat will be transferred from the pattern to the sand mixture, so that more of the sand mixture will be getting attached with the pattern and so which in turn will be increasing the thickness of the shell. Shell thickness, as I mentioned, is which is to be used depends upon the pouring temperature, size of the casting, and the complexity of the shape of the casting. So, once the shell of the proper thickness has been achieved, which thickness is to be used for a particular casting, that is achieved through the trial and error method. So, as per the casting shape, geometry, and the size, the proper thickness is identified, and once the shell is made, then it is required to remove the shell from the pattern. So, removal of shell from pattern. This is what is achieved, and in order to facilitate the easy removal of the shell from the pattern, like some of the agents are sprayed in the over the surface of the pattern, so that the removal of the pattern becomes easier. And once the shell has been removed, so proper curing is done. So, curing of the shell is performed in order to provide sufficient properties. So, curing of the shell is to be done in optimum manner, so that it gets desired strength and ability to take the load of the molten metal. So, means ability to handle the metallostatic pressure is achieved through the proper strengthening of the shell. In either case, if the curing of the shell has not been done properly, then it may lead to the over cured or under cured. So, in case of the over curing, the over curing will be reducing the lowering the strength of the shell because of the burning of the resins, and in case of the under curing, not just the low strength, but it also leads to the blow holes in the casting. So, it is a desired that the things are properly cured. So, for uniformity of the shell thickness, it is important that the temperature of the entire pattern is uniform. Say the pattern was of this type. So, heating of the pattern should be done in such a way that the temperature of the pattern at almost all locations is uniform, and this variation should not be more than 20 to 40 degrees centigrade, because the temperature governs the melting of the shell resin in the mixture, and which in turn affects the shell thickness. So, if the temperature is uniform, then shell thickness will also be uniform. Too large variability will be leading to the non-uniform shell thickness, and which can lead to the defective casting. So, shell thickness temperature, for uniformity of the shell thickness, the uniformity of the plate temperature or the pattern temperature is important. Now, we will see which for the casting the different types of the metals, we have to use the different mixtures for preparing the cells. So, for example, here we will have the two types of the sand, like silica sand and zircon sand. Then we have to use the resins and then additives. So, what is the amount of these constituents which is to be used when the different casting processes are when the different metals are to be processed by the shell mold casting. So, say for low carbon steels, what is used for low carbon steel, basically 63% of the silica sand and 30% of the zircon sand, 5% of the resin and 2% of the additives are used. While for the medium and high carbon steels, mostly it is the zircon sand which is used, 96% and 3% and 1% of the additives. For the grey cast iron GCI, basically 60% of the silica sand and 35% of the zircon sand and 4% of the resins and 1% of the additives are used. For copper alloys like brass and bronze, mostly the silica sand of the 90% and 6% of the resins and 4% of the additives are used. For aluminum castings, 95% of the silica sand, 4% are no zircon sand and 4% of the resins and 1% of the additives. For Mg alloys, for magnesium, this is for aluminum alloy and this is for magnesium alloys. Mostly zircon sand is used of the 95%, 4% of the resins and 1% additives. So, these are the kind of mixtures which are used for preparing the sand mix, sand resin and additive mixture for cell mold casting process. The cell mold casting process is used for the very simple shape, but with the much closer control over the dimensions and the surface finish. So, now if we see the this process is mainly used for preparing the components like IC engines, cylinder head and bevel gears. These are the two common types of the components which are prepared, apart from the many other fine components of the automobiles. Advantage of this shell mold casting process is that once the cell is ready, then we can pour the molten metal into the cell as per the requirement, so that after the solidification we can get the casting. But we need to consider here one point, that since the shell is of the limited thickness, say this is the shell of the thickness of the, like say 5 mm, 6 mm or 8 mm. So, it basically provides the shape to the mold, but it may not be able to handle the pressure of the molten metal. So, in order to make it capable so that it can handle the pressure of the molten metal, suitable support systems are used. So, it may be like say the grey cast iron support of the same shape as that of the casting, as the same shape as that of the mold is used, or for so this may be of the cast iron, or we may provide the backing of the sand also from the all the sides, so that it can take the metallostatic pressure of the mold. So, suitable support to the cell need to be provided, so that it can take the metallostatic pressure and the load of the molten metal without fracturing of the cell, so that after the solidification suitable casting can be achieved. Coming to the advantage, very close control over the dimensions is possible. So, accurate close control over the dimensions oblique tolerance is possible. So, accuracy accurate in dimensions. So, which can vary from say 0.013 to plus minus 0.13 mm. This is the kind of the control over the dimensions is possible, and the good surface finish is achieved like say 3 to 5 micrometer RA surface roughness is realized. Then the process is the surface finish and the close control over the dimensions. Then wide size range of the castings can be made using this, maybe as high as 200 to 350 kg size castings can also be made, and this process can be used for producing the very fine or thickness or thin sections, thin section features as low as 0.25 mm. So, the features of the thickness of 0.25 mm can also be produced with the help of this casting process. Since the permeability of the shell is good, so good permeability of the shell actually reduces the scope for the porosity. So, the casting is sound and it is by and large free from the porosity. Coming to the limitations, the limitation is that since the shell, for preparing the shell we need to prepare the mold. So, we need to prepare the pattern, and preparation of the pattern will be justified only in case when the large volume of the castings are to be made, because metallic patterns, preparation of the metallic patterns is an expensive affair, and that is why the metallic patterns for preparing the shell will be justified only when the large volumes are to be produced. So, the process is economical for large volume production purpose, and then the another limitation means the finish is not that good as it needs the machining. So, means the components produced by this cannot directly be put into the use, especially when the close control over the dimensions and the surface finish is needed. So, for those cases this process cannot be used, like the investment casting process for those metals which for those components which can be directly used into the service can be produced by the investment casting process, because they offer the good surface finish and the good control over the dimensions. Now, I will summarize this presentation. In this presentation basically I have talked about the principle of the preparing the shell in case of the shell mold casting process, and I also have talked about the applications and the advantages of this process. Thank you for your attention.